Okay. So good afternoon, everybody. I'm going to continue with the previous session, with the previous lab session that was about using data frames from Pandas library, also the use of series, also from the same library, okay? So just to make a quick summary of what we saw, okay? We learned what is a data frame and what is a series. We learned how to create a data frame. First of all, an empty data frame, then a data frame from a list, also a data frame from a dictionary of lists, and a data frame from a list of dictionaries. You can see that in this case, you can directly name all the columns, okay, but just by giving the name of the entries of the dictionary. Also, a dictionary of series. Yes. Oh, sorry. Yes. Sorry. Thank you very much. Okay. Now, right? Can you see it right now? Okay, let me. Okay. Thank you. Well, we learned how to create an empty data frame, a data frame from a list, uh, a data frame from a dictionary of lists, a data frame from a list of dictionaries, or a data frame from a dictionary of series, for instance. Okay. Also, how to load a data frame from a CSV file. We have here an example given the column names. Okay. Well, different options for setting the names of the columns. How to operate with columns. We can select columns just by putting in between brackets the name of the column that we are referring to. How we can delete a column, we can do it in two different ways. By the use of pop, which removes the column from the data frame and it returns the column. Okay, the pop function, do you remember that it returns the column and it actually modifies the data frame? And with the use of drop, we are not modifying the data frame, but it's returning another data frame with all the columns except the one that we are specifying here, or as it is a list, as you can see, it's they are brackets, and we can remove several columns. Of course, we need to specify axis equal to 1, since axis equals to 0, which is the default, it refers to rows. Okay, so you can see that it does not modify the data frame that we are applying the function to, but it returns a new data frame. We can select a range of rows. We can add rows, but in this case, to add new rows, what we have to do is to merge two different data frames. We can delete rows with, again, the drop function, but this time with x is equal to 0, which is the default behavior. I also taught you how to access a specific cell, which is not actually in the slides, but I show you that you can do it. For instance, if you want to access here in this data frame to this value, to the 20.0, you can access like this, df dot log, and between brackets you have to specify first the name of the row, b, and then comma the name of the column, which is 3. Okay. Also, you can access by the index, but in that case you need to use ilog, which is this is the row 1, since it starts in 0, and column 0, 1, 2. Okay, I'm going very fast just to make a summary of the previous day. Okay, other operations with data frames, you can get the transposed data frame with T. You can get the or you can get or you can set the labels of the axis with the attribute axis, the types of the columns, whether the data frame is empty or not, the shape, which is a tuple indicating the number of rows and columns, a size, which is the product of the previous two numbers, the values, which returns a numpy array. Okay. Also, you can get the first n rows or the last n rows of the data frame. Also, to get a descriptive analysis of your data frame, you can apply some functions to one or more columns. Okay, for instance, we loaded this data frame with names, ages, and ratings of people. And for instance, if you apply the sum function to all the data frame, what you get is the use of the operator plus to all the to all the rows of the same column. So of course the age, you get the summation of all the ages, the summation of all the ratings, but in the column of the name, you have strings. In Python, applying the plus operator to a string, you get the concatenation of both strings. Okay, so you get all the names concatenated. For instance, you can also calculate you can transpose the axis. Okay, so you can apply the sum function to rows, specifying axis equal to 1. You have count, sum, mean, median, min, max, abs, correlation, cumulative sum, cumulative product, describe, which is a summary of all statistics, and apply, which allows us to specify our own function. Okay. You have to be careful with some of the functions, because, for instance, I think it was apps cannot be applied to non-numerical columns. Okay, in fact, most of these functions does not have much sense to apply it to non-numerical columns. Okay, so I think it's very common to just apply them to numerical columns. Okay, we created our own function, which is an adder, but it's just a numerical adder because the sum function can be applied to strings, but this function cannot be applied to strings since we're starting this variable in 0. So if we try to make something like this, it will raise an exception. Okay. So here I am applying it to all the data frame, but the column which is called name, I apply my function. You see that here that I'm giving the name of the function that I am applying as a parameter here for the function apply. Okay. Also, we saw that we have lambda functions. For instance, this is a lambda function which normalizes a column. In this case, I'm normalizing the column which is called rating. Rating in the original data frame, you see that it goes maybe from 0 to 5. We are not sure, but we are going to move the minimum value of the column, which is this one, I think. This will be 0, and the maximum, I think it's this one, to 1. And all the other values will be transformed properly with a linear transformation. Okay, so what we sorry, no, I'm not subtracting here the minimum, I could subtract the minimum, and then I will achieve that. But what I'm doing is just to, yes, you see here that we have the 1 here, but we don't have the 0, since I'm not subtracting the minimum. Okay, to transform the range to 0, 1 to its value, we need to subtract here the minimum of the list and divide by the maximum minus the minimum. Okay, here I'm just dividing by the maximum. I'm skipping this part. So the maximum will be 1, but the minimum will not be 0, will be a little bit higher or greater than 0. Okay, well, uh, we saw the previous day until here. Do you have any doubt with this, or shall I continue? No doubts? Okay, perfect. So we are going to see filtering methods. Okay, first of all, we are going to define in this for example, we are going to define a series of booleans, and we can apply that series of booleans as a filter to a data frame. Okay, a series or a list, we can define both of them. It doesn't matter. You can define a list or you can define a series. Of course, usually a list is easier to define, but that is in the case that you are going to define it. But because sometimes you are going to obtain the filter from another site and you will obtain a series. Okay, so for instance, we are going to work with the same data frame as we were working with the people data frame. Okay, so let me show you my notebook. Okay, here, this is what we did the previous day. Okay, let me import pandas and load this data frame, which is the data frame of people. Okay, okay, this is the what we did. Oh, it is not working. What is it saying? Unsupported operand type for float and method. Maybe this? Yes. Okay. So I'm going to define a filter, okay? My own filter. Here I want to get the first person, also the second one, not the first one, not the next one. I want the next one. Okay, you can define any filter. It doesn't need to be the same as this one. I don't know how many of them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A couple more. Okay. Okay, if we get the filter, if we print the filter, we get the list. Well, so to apply the filter, well, I can also convert it to a series as I'm writing here. Okay, well, let's do it. filter series. It's a data frame series with the list given as filter. Okay, you see that it's quite the same. Okay, to apply the filter, I just need to say to access data frame of my filter. It's quite easy. Okay, so like this. You see that if I'm accessing uh, to a list in the data frame, if I'm accessing to a list of booleans, it selects a range or a subset of the rows. Okay, you see that it's not the same if I access, for instance, data frame of 8, I get a column. If I access something like this, I also get a column, but this time it's a column also in a data frame, okay, with a single bracket. It's a series, and with double brackets, it's it's also a data frame. I can also say it like this. Okay, this is something that we didn't see before. I can give H a name. It's I'm giving a list of the names of the columns. Okay. This is an error, of course, but oh, sorry. I wanted. It's still an error. Okay. But if I give here a list of booleans, but be careful, the list of booleans must have the same length as the rows or in the indexes of the data frame. You need to have the same number of elements in the list of booleans as rows you have in the data frame. Okay, like this. Filter. You get all the rows filtered only by those which are stated as true here. In this case, 0, 1, and 4. Okay. It also works with a series. Okay. You have it here. Well, but actually, this is not very useful, at least as we in this way of doing it. Okay, just specifying a filter by hand is not very useful. Moreover, you have to be very careful by putting the same number of elements as rows you have, and so on. Okay, so to solve this problem, we can also see that we can compare a column. You may remember that a column is actually a series. Okay, a data frame is like a list of series. You have several series, and each series is a column with a value. If you compare a series or a column in a data frame with a value, what you are actually doing is to compare each individual element with the value. And what is returned is another series of booleans. That is why I said, because actually when I'm doing this, it's much easier just to define well, not much, but it's easier to define just a list and then use it as a filter. But when you are doing this, you are obtaining a series, not a list. Okay. So, for instance, we can do this. We are going to compare the column name with Tom. Data frame, column name. Okay, and you see that what I am obtaining is a series of booleans indicating that the first row of my data frame had Tom as name, and all the other ones don't have Tom as name. Okay, so now the next step. Okay, this is what we obtained. So the next step is to combine the ideas. To combine that, by comparing with an element, we can obtain a series, and of course it will be a series with the same number of elements as rows we have in the data frame. So we can compare here this, which will return a series, and use it to filter our data frame. Okay. That way, we will be able to show all data from people whose name is Tom in my data frame. So what I have to do is now access here to data frame of this. Okay. Do you understand how to filter my data frame and obtain all the columns of the data frame by a condition in one of the columns? For instance, I may also obtain all the people whose age is greater than 25, for instance. You see that here I have rows 1, 4, 5, 7, 8, 9, 10, and 11. It is not showing rows 2, 3, 6, and I think 12. Okay, I can filter my data frame by conditions. Okay. Like this. Okay, this is the example that I just did. In this case, in the slide, is with 30, but it's the same. Okay, and I want you to do this exercise now. I want you to get the people whose age is greater than the mean age. Okay, try to do it and tell me the solution. Okay, let me know when you have it and if you obtain the result. Okay, we have an answer. Data frame of data frame 8 is greater or equal to data frame 8 dot min. Well, I think it's correct. Anybody else obtain that solution? Anybody else? Well, let's do something. React with a thumb up all all of those of you who obtained the solution, just to see. Okay, many thumbs up. Okay, perfect. Well, of course, it's something like this because I'm going to explain just in case somebody doesn't understand. Okay. Uh, First of all, I'm accessing. It is you have to think in this order. Okay. I'm accessing column H. Then I'm sorry. Instead of this, first this one. I'm accessing column H. To column H, I'm calculating the mean. Okay. Because of course, when you the mean function can make the summary of a whole column. Okay. Then this gives just a single value. If you calculate the mean of a column, it gives a single value. Then you access again column H and you compare all the column with the value that you obtained before, which is the mean. All this is returning a series of booleans. Okay, and then with true, of course, in the cases that the condition is fulfilled, that is the same as the V8 is greater than the mean, and then you filter the data frame here with that condition, with that series of booleans. Okay, everybody understands how to do this? Yes. If you have any problem at some point, of course, just ask me. Okay, no problem with that. Sorry, one moment. Okay. So let's continue. Well, I'm going to show you how it works. Well, here it just says it's greater, oh, greater than the mean. Actually, greater than the mean means that the equals should not be, but okay, it's just a minor importance aspect. Okay, so let me show you how it works. In this one. Okay, instead of comparing by a number, I'm going to compare by the mean, and we obtain 4 values. Of course, we can also get this can be useful to detect outliers. Okay, for instance, if you say here, I think that if we go back here, I'm not sure. Well, here you don't have a function to get the quartiles or percentiles, but you can obtain them. I think, let me check. Just, I'm going to write it. with just trying to remember, but if it doesn't work, I will look for it. No, no, let me look for it. Okay, it's quantile. Yes, you see that here you have quantile 0.75. Actually, is the third quartile. Okay. Also, if you say 0.25, it's the first quartile. But for instance, I can detect outliers, for instance, here by saying this. Okay, usually, we will see it later. If we draw a box plot, the outliers, which are stated in a box plot, are those which are farther. Well, in that case, the interquartile range is used. Okay, so in that case, we can calculate this value. This is the interquartile range. Okay, and but let me think. What something? It's 1.5. No, I don't remember. Sorry, one moment. The how to draw the box plot correctly. Okay, yes, I got it. The the outliers or the atypical points are those, for instance, considering the interquartile range, the atypical values are those which are greater than 1.5 times the interquartile range, well, the three quartile. Sorry, no. Sorry, it's third quartile plus, which are greater than the third quartile plus 1.5 the interquartile range. That is the correct. So this is the interquartile range, 1.5, and the third quartile is this one. Okay. So all the values that are greater than this value, you see what I'm doing, right? Third quartile plus 1.5 times the interquartile range, which the interquartile range is the third quartile minus the first quartile. Okay, this value, the values which are greater than this value, are atypical points. So I can access data frame of, and now I want to filter those edges that are greater than that value. Of course, in this case, we see that there are not atypical edges on the top part of the data frame, okay, from those whose age is very high. Also, we can filter on the other side of in the bottom part of the ages here, saying it's lower than the first quartile minus 1.5 the interquartile rents. There are no values, so there are no atypical values in my data frame. I don't know if you understand what I did here. Do you understand all the command? Don't you have any problem? No? May I continue? Okay. Well. So now let's continue with visualization. We are going to see how to visualize our data using another library. We are going to use MatPlotLib. Does anybody know how to use, or anybody of you already know MatPlotLib library? Okay, Tom knows it. Okay, perfect. Bit, yes, yes, yes. Okay, so that's great. Okay, we are going to see how to work it by how to work with Matplotlib as an standalone library, and also how to integrate it with Pandas. Okay, because you can integrate the library with Pandas, and it's great. Also, this is also part of data exploration. Okay, data exploration is very important, and of course, first of all, you have to get a description, an analytical description of your data, but it's also very important to have a correct visualization of your data. Of course, if all your data are numerical, you cannot plot it in n dimensions because we have limitations, but we can plot maybe one single variable or even a variable against another one or something like that, okay? So if you don't have Matplotlib installed, you can install it with pip, the same as we did with Pandas the previous day. Or if you are using Anaconda, for instance, or I don't know if you are using Spiders or PyCharm or PyScripter is another Python interpreter. Okay, if you are using Anaconda, oh, sorry, you can go to your environment that you are using. Here you can check if you have it installed, Matplotlib, okay? If you don't have it installed, you can go to not installed and install the library, okay? It's very easy. And otherwise, you can always, also with Anaconda, okay, you can go here, launch a prompt. No, this is not this is not what I wanted to launch, sorry. This is what I wanted to launch, the prompt. And you can type pip install matplotlib, okay? I'm not going to do it since I have already installed. Well, a very simple plot. We can create a line plot, which is very easy. We have to specify a list of the x coordinates of all the points to describe the lines. Okay, a line plot is a plot something like this. Okay, these are the axes, and let me change the color. Here we have points. Okay, a line plot is the plot which has a line between all the consecutive points. Okay, so you have to give two lists. The first list gives the values of the x components of the points, and the second list gives the values of the y component of the list of the points. Sorry. Okay, be careful since both lists must have the same size or the same length. Okay, so we can check how this works. Well, I also need to import the library. Okay, import matplotlib.pyplot, and I'm going to import it to make it easier as plt. Then I have to say plt.plot. I'm going to plot and give the two lists of points. The first list is just the consecutive integer numbers 0, 1, 2, 3, 4, 5, 6. And the other list, you can give whatever values you want. I'm going to write the same values as you have in the slides, but you can type whatever you want. Okay, and now if I execute this, it doesn't work. Well, it works here. Sorry. It doesn't work if you are using another interpreter. It doesn't work. Okay, here it works because the Jupyter Notebook and Jupyter Lab is very clever and it knows that you want to do this. Okay, but usually you need to type this as well, the command so. Okay, because otherwise the plot function initializes your plot. It's like it has in mind all that you want to plot, but it doesn't actually show it. Of course, because if you are typing it in a command line in a prompt, it's the command show, the one that opens a viewer, like a navigator to plot or to show you your drawing. Okay, then here, as I said, the notebook, the Jupyter Notebook is already clever. It knows how to. It knows that it has to plot it to draw it. Okay. So you see here that, of course, sometimes with this is just enough, but if you are using another environment, you might need to type also the show function. Okay. Of course, you get this. You get the same that you have here in the slide. Sorry, is what you obtain here. Okay. We can also modify the aesthetics of the plot. For instance, we are going to add a title and labels for the axis. Okay. To do that, after plot, you have to type, for instance, plt, the name of the library, dot title, and give a name to the plot. For instance, my plot. If I type here plt dot title my plot, you obtain this. Okay. Actually, the so is not necessary in this case. Okay. But I'm going to leave it anyway. My plot. You have here the result. Let me check something. I'm not sure if I type this and here I type this. Well, you have to do, yes, here in the Jupyter Notebook, you have to type everything in the same cell. That was what I wanted to try. Okay, if you separate it in different cells, it interprets that it's a different drawing. Also, because it's like, I think that it implicitly that's a show after the end of the cell. Okay, because this is the behavior when you make a show. After making a show, it's like the buffer, the drawing buffer is emptied. Then you get this. Okay, so everything in the same cell. Also, we can set the labels of the axis. plt.xlabel, xlabel for instance, and ylabel. Okay, you obtain this. Okay. It is also possible to add a third parameter, because here we're specifying two parameters to the plot function. The first one are the x components, and the second one are the y components in form of a list. We can also specify here a third parameter to change the type of the line of the marker and also the color. Okay, by default we have this option in the third parameter. Oh, sorry. The third parameter is a string. The first character of the string determines the color. Oh, I'm sorry, because I'm just saying that I didn't translate the colors here. They are in Spanish because these slides I made them original in Spanish. But this is blue. I will translate it. Okay, this is green. This is red. This is like light blue, cyan. Okay, magenta, yellow, black, and white. Okay, I will translate it before uploading them. So the first character specifies the color. Of course, it's the first letter of the color in English. Okay, and then you can specify one or more characters to determine the type of line or the type of marker. With a single dash, we obtain a solid line. Two dashes is a dashed line. Dash point is a dash dot line. This is the column is a dotted line. A point is a point marker. Okay, these are lines. These are markers. A point is a point marker. An O, be careful, this is an O, not a zero. An O, lowercase o. Okay, it's lowercase, very important. It's a circle marker. This accent, the circumflex accent, is a triangle up marker. Okay, a lowercase v is a triangle down marker. Also, you have because there are many options. Okay, you don't have all the options here, but you have also the lower and greater characters are also triangles. The first one, it's a triangle with the like this one, okay, and this one is like this one. You can also set a square marker with a lowercase s, a star marker with the asterisk, or with a lowercase x, you have an x marker. Okay, I think I have a question. Yes, do we have convention about marker and type of line? Like this type of line is for economics data and this is for etc. Well, I don't actually know if there is a convention about this. I try to use what I think it's better to understand the diagram. Okay, I don't actually know if there is a convention. Okay, I don't know if anybody else knows if there is a convention. As far as I know, there is not, but maybe there is a convention because, as I said, I don't know. I don't actually know. I try to use the one which is better for my data to interpret the data. Also, when if you have it into account that you might have different plots in the same one. Okay. Okay. So let's change the yeah, no problem. You're welcome. Let's change the option here. For instance, I want a dashed line and red red dashed line. Okay. Or I want uh, triangles, but green triangles. Okay. See this? This is one of the ones that were not originally written. Okay. It changed the orientation of the triangle. Or an O, lowercase o, an X, or dash point. Okay. Whatever you want. You can combine them as you want. Also, we can overlap several plots in a single drawing. Okay, if you specify plot and then again plot, each plot is a different line of the in our diagram. Okay, in our plot. So here we have this one. Well, in the slide is a red solid line, and I'm going also to add another one. In this case, you can specify other X components. Okay, they don't need to be the same ones. For instance, 7 and here 17. Okay, and this one I can also change the style with blue. Sorry, with blue and circle markers. Okay, you obtain something like this. Okay, you have here the same again. Okay, now you have an exercise. I want you to plot those functions, those two functions, in the interval 0, 10, using a step between points of 0.1. And you need to use two different styles of line. Okay? I want you to try to do this exercise. And let me know when you finish. Has anybody achieved it? Not yet. Okay, I'll wait for a couple of minutes more. Let me turn the lights on. Okay. So just the first day that it gets dark, well, the second day that it gets dark earlier, one of my lights decided to fade. Perfect. Okay. Do you have it? Not yet. Anybody achieved it or not? Please say something for me to know that if you got it or not. Still on it. Okay. So then I will wait a little bit more. Okay, somebody wrote something. You create a range function. Oh, what says here? I don't know, Laura, did you click on something by mistake? Maybe? Here we have the x components are range here. Okay. Let's see something. Let's see what we obtain with the comprehension list that Ostap wrote in the chat. Okay. Okay. Do you see what is the problem here? Well, actually, this is not something which is related to our class, actually, but just to see. Okay. Okay. Tom wrote something also. Silu wrote that you have the first one. Also, Martin. Okay. We are obtaining all the solutions now. Okay. Silu space. Okay. Okay, we have several solutions. Okay. Well, I saw one solution that directly gives this list. Also, with this solution, what we obtain is just this. But in the slide was saying that we need a step between points of 0.01 because if you give a whole unit of space, it will not be as smooth as a function. Okay, the solution is given by Alvaro or given also, I think, let me check who else came, or by Tom, of course. The solution in the slide is the same as the one given by Tom, I think. Okay, you have to import NumPy because, of course, you have the problem that the range function in Python cannot work with floats, just with integers. Okay, so what we can do is to import NumPy and renaming it as np, and then call np.arrange. Arrange allows us to give also a floating point step. Okay, and in this case we don't need this, I think. Of course, you see what we obtain. The only this is actually 10. Okay, not 11. To go to the 9.9. Who else? Let me check. Well, and of course, and regarding the functions, I think that most of you can, once you have this list, most of you can have the answer, right? Of course, it could be something like this. For instance, for the f function, we can do it also with a comprehend. Well, the x is not done by a comprehension list. It's just a NumPy arrange, since it already produces a list, if I don't remember incorrectly. Well, it's not a list, it's an array, but it should work anyway. Okay, these are our x values. Then the first function, well, I named it here like y1, but you can name it as f or whatever you want. Okay, y1 would be with a comprehension list. We just write the function here. It's the value elevated to the to 2 plus 2 times the value minus 1 for all the values in the array or in the list. Okay, so the value squared plus 2 times the value minus 1 for any I in the values of x. And the second function, we have to do the same. Okay, well, I'm going to write already this for I in x. And here we have to write the e function, the exponential function, okay, elevated to, in this case, to the value divided by 2. To get the exponential function, okay, we can write an approximation by 2.71 or something like this, but we can be more accurate if we import math, library math, and we type here math.exp from exponential the value divided by 2. Okay, and this gives us the values. Let me check. Oh, is it also included in NumPy? Because I saw that Alvaro wrote something like this. Well, yes, maybe then in that case, math is not necessary here. Okay. I'm checking your solutions. Okay. Here, okay, Silu included the data in a data frame. Well, it's much more complicated, I think, and you're applying. Well, but you are applying a lambda function. Well, it's also valid your approach, of course, but I think it's a little bit more difficult. Okay. Yes. Also, we have here Martinez apply, which is okay. You defined a function as a Python function. Okay, perfect. Tom wrote it similar as I did. Okay, perfect. Different solutions for the same problem. I like it. So then we are going to plot both functions. Plt dot plot x, y, 1. The first one, for instance, with red and dashed line. No, sorry, this is red and solid line. Plt plot x, y, 2, and with blue and dashed line. Of course, maybe you also need, depending on your environment, the show. Okay, and you obtain this. Perfect. Now let's plot this. The difference with the previous one is that here we don't have the divided by 2 in the exponent. It's just that's the original exponential function. Okay, e elevated to x. Okay, we can do the same. Let me modify this one. We remove this divided by 2. And here we have a problem, of course. We have the problem that we cannot actually see the behavior of the quadratic function, the parabolic function, okay? Because the exponential function grows very fast. Well, this is what we have here, okay? To solve this problem, we can create different subplots in a single figure. Because, of course, in this case, this is very convenient, but in this case, it's not convenient to draw both plots in the same figure. So we can use the subplot function to move between different subplots. First of all, I need to resize my environment, because actually by default the environment is squared. So I want to say that now the proportions are 8 versus 4. Okay, you can by changing the number, the scale, you can make it bigger or smaller. But what it's very important for us now are the proportions. I'm putting 8, 4, horizontal 8, vertical 4. The horizontal axis will be as twice as the vertical axis, okay? So here I'm going to write this plt dot figure, and I have to give the parameter fixed size equals to 84. Okay, you see that I'm reshaping the figure and saying that the horizontal axis is twice the vertical one. And now I can refer to a subplot. How to refer to a subplot? Okay. Let me. I have to remind what are the parameters here. 1, 2, 1, 1, 2. Let me check something. Okay. Yes. You have to. Yes, you define a matrix of plots, but here the first two parameters define the dimensions of the matrix of plots that you are going to create or that you are using, okay? You have to give the same value if you want all the plots to be of the same size, okay? Yeah, we will see later how to create plots with something like this. One plot here, one plot here, and one plot here. In that case, these two first parameters are different. But if we want, for instance, all the plots to be of the same size, we need to write the same in all the cases. In this case, we are saying that we have one row and two columns. Okay, we're defining something like this. Okay, and this is the position of the plot that we are going to specify now. Okay, the first one is this one, the second one is this one. If we are working with 4, this is first, second, third, fourth, okay? So, for instance, we are going to start with y1. We are going to focus on subplot with one row, two columns, and specifically the first one. We are going to set a title for that subplot. Okay. In this case, the title only affects to the subplot. And now I'm going to set my focus on subplot. Also with one row, 2 columns, and the second one. In this case, my title will be subplot 2. And now I'm going also to use a super title. It's a title with for both plots. plt dot subtitle super title using subplots. And you see that we obtain this. Okay. We can also, for instance, if we do something like this, okay, it warns me that I'm, in this case, adding an axis using the same arguments. Well, it says to me that, of course, I'm overlapping both plots in the same one, of course. I can maybe say something like this. I'm specifying a 2 by 2 matrix. I will be, in this case, okay, and I'm specifying subplot 1 and subplot 2 here in position 1 and in position 2. Well, here the problem is that, of course, in this case it should be squared. Okay, but if I give position 3, it's here. Okay, you see that position 1 is here, position 2 is here, position 3 is here, position 4 is here. Also, imagine that I'm going to specify this as 2 by 2, but this one will be 2 by 1, and I'm specifying the second position. Okay, you see that I'm saying that this case the matrix has 2 rows but 1 column. 2 rows, 1 column. Sorry, 1 column. That's the reason why it expands along all the columns that we have on the top part. Okay, because on the top here we have 2 columns, but in the bottom one we have only 1 because we are saying this here. Okay. Also, if we change this like this, it's the same, but putting the second plot along both rows. Do you understand how this works? It might be maybe a little bit confusing. Also, you have to be careful since here if you type or here too, it doesn't work correctly because we are overlapping our plots. Okay, we need to be careful with this. Do you see how it works? Do you have any doubt on it? No? Shall I continue then? Okay. Well, this is the result. Okay, let me clear the slide. Okay. Okay. Now we have seen that how it works, how MatPlotLib works. Okay. Now we are going to integrate MatPlotLib with Pandas. Okay. So using the last data frame that we had loaded, okay, we have the data frame of names, ages, and ratings. And now, for instance, we are going to create a data frame, sorry, a scatter plot, okay, scatter plot using two continuous columns of the data frame. Okay, scatter plot needs, of course, two continuous values, the x value and the y value, but both variables need to be continuous. Okay. What we have to do in this case is data frame or our variable df dot plot. Okay, we have the method plot in data frame, the data frame class. So we just call that plot function, and it knows that it will need to draw it with MatPlotLib. Okay, so I say that the kind of plot that I need is a scatter plot. Scatter plot. Well, the kind is just scatter. Okay, the x values are taken from column H, and the y values are taken from column rating. Also, if I want to give a title, I can give it here. Well, if I just do this, I obtain the plot, but I can also write it here, plt.so. Okay, I think that, well, once you do this, you can also, well, let me check something. plt.xlabel, no, y label, sorry. Of course. You see here that we can use all the previous functions that we learned. Well, we can write the title here, but we could also write the title here, like this, okay? And here, by default, the name of the axis are the names of the axis are the names of the columns. But usually, or sometimes, we don't want to be exactly the name of the column, because maybe the name of the column is not descriptive enough or whatever. So in that case, we can rename the labels as we know, as we did before. Okay, plt.ylabel, and specify the new label of the axis. Okay. Well, here the change in the label of the axis is not done, but it's the same. Okay. Okay. By default, if you specify here it's scatter, it already knows that it's a scatter plot, so it's the same as specifying before the option. Well, the color is the color by default, blue, and the marker specified with a lowercase o. Okay. Well, we can also get a bar diagram or a bar chart. Sorry. In a bar chart, we have two different types of variables. We have a discrete or categorical variable for the columns, and a continuous column, and a continuous value, sorry, or continuous variable. For instance, we may plot this, plot kind is a bar term, the x is given by column name, and the y is given by column rating. Okay. Okay. Maybe you need to add the plt.show. You can also swap name and rating. Oh, no, you cannot. I thought that you were going to obtain the transpose diagram. I don't remember the name. Then the same as columns, but with a row. Okay, it's like a row chart, but no, it doesn't work like that. Okay, this is what you obtain. Also, with categorical and continuous variables, you can also use this one with continuous and continuous. Okay, it's a line plot, the same as we saw before. Well, df.plot. You see that the function is all the time the same. Plot kind. Kind. In this case is line. Name. Age. Okay. Now, in the case that we want to add two different lines, in this case we need to specify that they must be plotted in the same axis. Okay, let's see what happens. For instance, okay, I'm going to create another one here with the same plot, and also with the rating. By default, I obtain two different plots. Okay. To overlap them, I need to get the axis by calling the PLT function, which is called GCA, which is get current axis. Okay, get current axis, and specify thus that this line must be written in the axis that I stored in the variable x, and this one must be drawn also in the same axis. In that case, you obtain this, and of course, it automatically uses different colors for the lines. Of course, you can also change the color. For instance, you see that this is yellow or orange, I don't know, but you can specify here that the color that you want is red. Okay. This is what you can find here. You can also combine two different types of plots. For instance, I may want name and age, but well, here I want column with name and rating. No, it doesn't work. Well, because I need not a column but a bar chart. Yes. Yes. Sorry, it's the name of the chart is not column, it's bar chart. Okay. Okay. You can also change the color. Okay. This is what you have here. We can also obtain a histogram of a continuous variable. Histograms are very useful. So df.plot in this case, the kind is hist. Oh, sorry. It's the variable that we want to give now must be specified here, okay? We cannot specify it here because the histogram can only be plotted with a series. So we need to specify it. Sorry. We need to specify it by accessing to the column of the data frame. Okay. Okay, you can, well, here you have also a title that I didn't wrote, but it's the same. And now the box plot, which is very, very, very useful, as I said, for detecting outliers. Okay, you can inspect the outliers with a visual inspection, like with a box plot, and then you can obtain where the outliers are by using the filter that I wrote before. Okay, but before it's better to identify the outliers visually. Okay, but once again, you need to filter the column that you want the box plot here, and then plot and say that the kind of box of plot that you want is a box plot box. Okay, as we saw, there are no outliers. Okay, and finally we can also combine multiple plots in a single figure. It's the same as before. Okay, if you remember, what we needed to do is to say here to resize our figure. I'm going to copy this. Okay, here we need to resize our drawing, our figure. In this case, we are going to give twice the length of the vertical axis to the horizontal axis. Then I have one row, two columns, and the plot one will be a box plot because this is very useful for plotting different box plots in a single figure, because usually you want to plot the box plot of all variables, and then then it's very useful to plot all of them using this subplot command. Okay, so subplot, and then we can say here df dot plot, well, df, sorry, of h dot plot kind equals to box. We can also set the title if we want. And now one row, two columns, position 2. And we are going to plot the rating. Dot plot kind equals to box. Okay. Well, we can, instead of to plot 1 and 2, we can, well, you see that you already have here the name of the variable. Okay, it's not necessary to write the name of the variables on the top, but just to make an example, you can write them. Okay. This is what you have here. And finally, you have here an example of 4 diagrams. Of course, we reshape this 8 by 8 for the size of our figure. And here the matrix size is 2 by 2. The first 2 positions are what I already have. The third one, subplot 2 by 2, position 3. df.plot, I'm going to plot a line plot using as x the name, sorry, the is the name, and I the age. Okay. You see that it happens this, and this is something. Okay, let me check. This is something that, of course, here we didn't need to do this, but here I think it's because they are different types of diagrams. We need to set again that the axis that we want to use are all the time the same axis. Okay, so we can just write it here. X equals to plt dot get current axis, and here say x equal to x. Here again, here again. No, not working. Sorry. Maybe using this. Yes. I don't remember why. I will look for it. You need to specify here. Oh yes, I already know why. It's not the same axis all the time, because actually if you have here this, you are using the axis before the subplots. Now here you need the axis of subplot 1, the axis of subplot 2, the axis of subplot 3. Okay. One question, if you use a column as the index column, then you can access that column in the same fashion as, or you must, I don't think, Anton, that I think that I don't understand your question. Sorry. If you use a column as the index column, oh, okay. A column as the index column, you can access that column in the same fashion. I think that in that case you can filter by that column. Okay. Oh, you used names, and doesn't it work for you, or it works? Actually I have never tried that. Okay, you have that, and does it work or not? Okay, that is what I fear, because of course they are not actually data. They are a way of indexing your data, but not actually data. Okay. So that's the reason why it doesn't work. You should not. Okay. Okay, no problem. So, well, I'm going to add the last one, the last plot. Fourth one with the rating. Okay, you see it like this. Or, for instance, I might remove this and here saying that it's just a matrix with 2 rows but 1 column, and in the third position it doesn't work. 2 column. Sorry, it's the opposite, I think. No. Yeah, the problem is that yes, I was correct, but I confused the number because, of course, if you have 2 rows, 1 column, you only have 2 positions, here or here. Okay, you see the how to construct the matrices, okay? Right? Well, this is everything for today. Well, this is the result. Okay, you have the result here. I don't know if you have any question of what we saw today, anything that you want to ask. No? Okay, so thank you very much for attending. I'm going to stop the recording, but don't go out that I want to remember something, okay? Yes, Akos has a question. Okay, let me know your question. Mm-hmm. You joined. Okay, that is what I'm going to say now. Okay, I'm going to stop the recording because this is something that is not relevant for the class itself. Okay, so thank you very much.